All right. Can you guys hear me in the back? Yeah? Okay. Thank you. Thank you for that amazingly upbeat introduction. I really appreciate that. So just to make sure I'm in the right place and that you're in the right place, this is the room for CSE 340. Yes, most of the people nod, some people leave. That's fine. Principles of programming language. Sorry. Okay, so first things first. For those that don't know me, which is probably the majority of you, I'm Adam Dupay. This is my first undergrad class I'm teaching here at ASU, so I'm pretty stoked about that. I hope you guys are excited about that because I think we'll have a good time. A little bit about my background. I did 5 years at UCSB where I did my undergrad and grad, kind of like the 5+1, or what do you call it here? Or 4+1, yeah. So that similar program. Then I went to Microsoft where I worked full-time as a software developer there, doing coding stuff. And I decided that I really liked doing research, so I went back to Santa Barbara to do my PhD. And there I worked on security research, so automatically finding vulnerabilities in specifically web applications. So through static analysis techniques or some dynamic analysis techniques. And so that's really my research focused, and that's why I'm actually really excited to be teaching this class, because this compilers and the principles of programming language really form the basis for a lot of the bug finding stuff that I do. So if you can, using the exact same techniques we're going to kind of learn about in this class, we can actually try to find and identify vulnerabilities in a program without even executing it. Okay, so before I continue, questions about me, my background? Yeah. What languages did I use at Microsoft? My team, it was all, I think, all C#, I want to say. So yeah, the app I was working in was written in C#, which is actually a really fun, kind of cool language. It's like Java, but I feel like better. It's like if they actually designed Java to be useful. So did I say that out loud in front of a bunch of people? Okay, that's fine. Cool, any other questions? So I'd be happy to talk to you later on, whatever, as interviews come up. You want some feedback or some tips on how to do interviews, I'd be happy to help you there. More questions? There's plenty of spots, people in the back. There's lots of seats. We have a lot of people enrolled, so. Does that say the limit is 250 on the room? Yeah, I think it does. All right. Maybe we can fit 10 more people in here. Okay, so this course, 340, this is the syllabus. There's a link to it on my ASU. You can also get to it from going to my website, adamdupay.com, click teaching, classes. It's pretty easy. I have to assume at this point everyone knows how to surf the web, use a web browser. So we meet Monday, Wednesday, 2:30. My office hours are here. I have 3 hours of office hours a week. And you can also email me for appointments. I don't think you need to take a picture unless something important's happening. That is all on the web. It's all public, just FYI. The course, we have a course mailing list, which I'll get to in a second. The lead TA for the course, Mohsen, he's going to be in charge of the homework, the project submission system. He couldn't be here today, so you'll get to meet him and see his face on Wednesday. Our other TA, Sai, is here. He's the one who got me lost today. That's why we're late. So Sai, wave to the class. Yes. Okay, so Sai also has 3 hours of office hours a week, Monday, Wednesday, Friday. Your office, we need to find you a place, but it will be in Brickyard, close-ish to my desk. And Mohsen has 4 hours of office hours a week. So together, somebody who's really good at math, what is that? 16. 3, 3, and 4 is 10. 10. 10. Guys, I know it's the first day, but you can wake up a little bit. Yeah, so we have 10 hours of office hours a week, so please come and talk to us. So that's basically what this section is about. So we've tried to distribute it throughout, at all days of the week, there will be office hours. Some in the morning, some in the afternoon. If you can't make those times, talk to us, email us. We'll also communicate with you if we have to change or move around office hour schedule. What we expect from you, we expect that you'll actually have done some work or some prep when you come into our office hours. You just come in and say, well, I don't understand problem 2 on the homework. Well, that sucks. Okay, what actually don't you understand? What have you tried solving? What ways have you tried solving it? What didn't work? That shows us that you put the time in to think about it, and that means we can help you more effectively, so it'll greatly help all of our times. So yeah, that's basically what this is about. And if you have questions about the programming projects, we also expect that you've made an effort. If you come in and say, I don't know what this error message is, and I Google that error message, and the first result tells me exactly how to fix your problem, that you did not do sufficient research to understand that problem, okay? Then I don't know what I'll do, but don't do that. Because that's silly, right? If you can help yourself, that's awesome. If you can't and you're stuck with and ran out of options, we're happy to help you out. Questions? Office hours? Basic stuff? You guys have to raise your hands up really high too. It's difficult to see. All right. So all the communication for this class is going to happen over this web page and a mailing list. So I'm not going to have a Blackboard site most likely because I feel like this is a lot easier and a lot more maintainable. So part of your first assignment will be to sign up for the course mailing list. So the TAs and I will make announcements to the mailing list. You guys can ask questions to the mailing list. Obviously, I love it if you guys help each other out because this is going to be a very difficult course. So I am very happy if somebody has a question. Hey, I'm getting this weird, obscure compile error, and I've looked at Google and I can't find any reference to it. Does anybody know what's going on? And somebody else says, oh yeah, I had that same problem. The problem is you're compiling 64 bits instead of 32 bits or something weird, right? So try deleting this file and recompiling. That's totally fine. But if you send somebody code and be like, oh, this code solves your problem, right? That's a violation of academic integrity, and that's going to be very bad. It's going to make me be mean, and I don't really want to be mean. So there's a great link here. I advise everybody to read this article. I'm going to test the Wi-Fi to see if the Wi-Fi works. Yes, it does. Okay. How to Ask Questions the Smart Way is a fantastic essay that will tell you exactly what we're looking for to help answer your questions effectively. It basically boils down to what I've been talking about. So do your homework before you ask questions. If you just ask thoughtless questions without doing any work or effort or looking at things yourself, then we'll help you because that's what we're here to do, but it's not going to be a good way to spend all of our time. Oh, and sometimes, so if you email us, feel free to email us directly, obviously, if there's something sensitive. But be advised that when we reply, we will oftentimes reply to the whole mailing list because this helps cut down on questions that everybody has. Questions? Course communication? Cool. Okay, prereqs. That should be fine. Everyone here is past that. Okay, the textbook. So I have a link on here. The bookstore should be either today or tomorrow having the textbooks. I don't know if they do or not. It's recommended. So this is actually the second edition. This is the one I have. It's a lot cheaper than the third edition. So keep that in mind. And the content from there is going to be very much the same. So what I'm going to do is I'm going to give pointers to the book of the stuff we cover in class, but I'm not going to assign any reading out of the book. So you can use that as a supplemental to help you understand the material better. Does that make sense? Cool. All right. So here's just a calendar of the course events. Some things you'll notice on there that we'll talk about. The first project is due in a week. Yeah.
Is there a place where we can find this?
Yes. You can go to my website, teaching, classes. It's right here. It's linked to the syllabus. It's also in my ASU. There's that syllabus link that goes right to this page. So yeah. Cool. Okay. So things on here. There's midterms exams scheduled, so look over this, make sure you understand we're having a midterm on the 30th. Then we're going to have our next midterm on the 18th, and the final exam is going to be on the 7th. So the exam dates are fixed. If you have anything in accordance to any of the policies or whatever, come talk to me. Questions? Okay, we get to the fun part. So this is going to be a difficult class. So I'm not going to lie to you and tell you that it's going to be easy. You're going to have to work really hard in this class, especially if you don't have strong programming skills. So all of the projects in this class are going to be in C and C++, and you're going to be writing big projects that are complex, and they're going to challenge you, hopefully in good ways, but I think you're going to have to understand new abstract concepts that we talk about in class. You're going to have to understand new programming, completely new ways of thinking about programming, and you're going to have to implement complex systems. So if you don't think your skills are up to snuff, then I would say take this course another semester maybe. Questions? There's lots of people scratching their heads. Yeah, got it. Okay. There's going to be 6 written homework assignments. They'll go over the concepts covered in class. They will also help you with the exams. So the stuff on the exams will be in similar formats to the homeworks. 2 midterms. So I'm going to say this now. I know I'm going to have to say it later, but everything it could potentially be on any midterm or the final. Okay? So asking, is this going to be on the exam is a silly question because the answer is yes. And the more questions I get about that, maybe the more I put something on the exam that would be asked more. So just so we've gone over this, we're clear. All right, programming projects. There's going to be 5 programming projects. The first 2 are going to be the first one should be very, very easy. We'll talk about it in a second. But they get more and more complex. So all projects are going to be done individually. So there's going to be no pair programming, no teaming up. This is something that you're going to have to figure out and solve on your own. All right, now there's going to be a final exam, comprehensive, cover all the materials. Cool. This is the breakdown of grades. Can somebody who got the first answer to make sure that that lines up to 100? It does? I got at least 1 verification? Good. Otherwise, you guys just lose those points. I'm just kidding. Okay. Preliminary grade thresholds. So this is right now what I'm going to put them as. So it means obviously if you get above that threshold, you get that grade. It all depends on how this course goes. I may lower those thresholds, right? I may make an A be, 92 or 91%. It all depends on how everything falls, but I won't go up. Okay, does that make sense? I won't make it more difficult to get one of these grades. So let's have an example. So if you get an 90%, right? That's guaranteed at least an A minus. It could be an A depending if I have to go down and make everything match up. Does that make sense? Okay. If you have questions, raise your hand. We're all friends here. It's okay. Yeah. Are there going to be any quizzes? No. Maybe? I don't know. No. No. It'll be what's on here. I won't try to throw any curveballs. Okay. Homework due dates. Homework are due online by midnight on the date that it's due. I'll have a link when I release the first homework assignment. We'll release how to submit the homework. No late homework accepted, so don't try, don't ask. Projects. Projects will each have a date and exact time that they're due. For each day that it's late, it's going to be 30% is going to be taken off of whatever grade that you get. So even if you complete the project 100%, if you submit it a day late, the most you can get is 70, and it goes down 30% day after day. I think it's pretty clear. Yeah.
Isn't the whole 11:59 to 12 a.m. a little extreme?
Isn't it a little what?
Extreme. Like if somebody gets there at 12 a.m., you're really going to take off 30%.
depends on what reason they give. If it's 11:59:59, it also depends on why. Like if these are going to be big projects, so if you're really going up against the wire here, you're not going to be successful. So you should not be doing that. So submit it early. You'll have feedback right away that tells you that this was right or not right, and so then you can know in advance. Yeah.
Are you going to be able to submit projects more than once? Like say if you submitted it early, ran it again, discovered a bug, you resubmit
Yes,
it?
absolutely. Yes. I believe, I'll have to check with Mohsen because he's in charge of that system, but I believe it's unlimited submissions. So you can keep submitting, but obviously don't go make a change, submit it, and then be like, oh, it doesn't compile because I forgot to actually compile it on my own computer before submitting it, right? So don't use it as an oracle, but yes, there's a hand over here. Yeah. Yes, there will be, well, I'll show you in a second, actually. How about that? Assuming everything works. Yeah. More questions? All right. So maybe as you can tell by, well, actually probably only these people can see, maybe you people. I'm going to try to record all the lectures in class because I know whatever your schedule, you can't make it, and you have to ask me what's going to be covered. So I'm going to try to record the audio and the screen here. So you get to know what we talked about in class, and I'll try to post these, but this is not guaranteed. So you're all adults, you're responsible for the material covered in class. If I forget this thing, I'm not going to stress out about it and record another lecture for people who weren't here. I'm just going to lecture. So, it's, and I'll post the slides, all the notes, as much material as I can, and pointers to the book. Questions? Yeah. Any extra credit? Probably not. I'd say no at this point. Unless so I mean, the projects are going to be already hard enough. I don't know that having extra credit is going to be a good thing. So I'd say no at this point. That's why the A+ is at 97, right? All right, cell phones, put your cell phones on vibrate or silent. I feel like that should be pretty easy. If you need any special accommodations, let me know. We can talk about this. Okay, this one is very important, so I'd like everybody to pay attention and listen. I take plagiarism and cheating very seriously. So part of what you're getting out of this class is the ability to create a complex, interesting system. And so by plagiarizing somebody else's code or helping somebody plagiarize, that's, to me, like one of the worst things you could do. Just take the 0. I've already caught a number of people cheating, and I don't want to catch any more. It's a lot of work for me. It's a lot of work for the TAs, but I'm happy to do that because I think it's fair to everyone else who's actually putting in the effort. So if you're sitting there and it's 10 minutes to the deadline, you're like, oh, I don't have it quite, but oh, my buddy's got everything all finished. If I just oh man, they'll never notice. We will find it. You'll get a 0 on the assignment and a letter grade docked in the course. It'll get reported up to the dean's office, so they keep a record of it. And if it happens again, you get very serious things happen. So, I don't want any of you to be like that. So come talk to us. If you're having problems, come to us. If we find you cheating and you go, well, it was just so hard. Yeah, okay, it was hard, but you never came to office hours to talk to us. Or you never asked any questions on the mailing list. So it's really up to you to monitor that. Some examples, sharing code with a fellow student, even if it's a few lines. Collaborating on code with a fellow student, so even if you both worked really, really hard on it together, that's not a good excuse, it's still plagiarism. Submitting another student's code as your own, that should be pretty obvious. Submitting a prior student's code as your own, also plagiarism. Okay, and this is something I do have to cover, so please do not post your projects online. I know for a lot of you, you want to build up an online resume for employers so they can see the stuff that you've done in class, and they can hopefully give you a job, and they can see what an awesome coder you are. I'm here to tell you, I've worked in industry. Everybody takes classes and does class assignments. right? So the best way to get noticed is to do something outside of class, something different. So instead of thinking, hey, maybe I should post this project on my GitHub, think, hey, I'm going to create some new cool thing that's related to that, some interesting type system that we didn't even talk about, and I'm going to put that on GitHub. Because employers are going to love, they seriously eat that stuff up. If you go, oh yeah, that website on my GitHub, yeah, I created that in my free time. I'm like 100 people use it. They go, wow, people don't do that. They just do the bare minimum in class, and you went above and beyond. Because it really hurts the other students. It takes away that temptation for students to Google CSE 340 Project 2 and find a bunch of stuff, right? So protect your fellow students, protect yourself. Don't post your code from this class online. Any questions about the plagiarism and academic integrity policy? Yes?
What about using code from like Stack Overflow?
So using code from, yeah, so if you use code from other sources like Stack Overflow, or even if you find a library function or a library from somewhere else, I'm totally fine. You can include that, but you have to include the attribution, right? So in your comments, it should say, hey, I got this code from this Stack Overflow thing. If it's something small, I think that's fine, right? If you happen to find something that does exactly what we're talking about in here, and you say this entire code came from Stack Overflow, well, great. It's not like, it's not plagiarism, but then you did nothing, right? It'd be like in an English class submitting an essay as a Wikipedia article and saying, the Wikipedia article on ethics says this, right? It's not plagiarism because you attributed the source, but you also didn't do anything. So that's my policy there. Yeah?
Couldn't we attribute other students? Then it wouldn't be plagiarism.
It is, that's true, but I'm expressly forbidding that. I'm saying no. Because then it's one thing if you find one thing online, right, that somebody else wrote in another context that's helpful for you. It's something completely different if you're both working towards the same goal and you go, oh, hey, look at that awesome function you wrote to do that. I'm going to not write that. Yeah?
Probably, so like stuff, you don't need like huge sections of code, right? You mean just like an individual function or like a loop or
You mean from using from somebody else?
Well, like from if I look on Stack Overflow, it's like you mean like small things like you can't copy
Yeah.
sections, right?
Yeah, I would say, yeah. Use your judgment. If you're looking at it and going, man, this is the entire project, don't use that, right? But you should also understand how that code works too, right? If you just, you don't want to be one of those copy-paste coders who just goes to random websites. Literally, when I was working in Microsoft, I was one of the product that we were working on, we were making an XML-based tree, so you could click on the link in this tree, and then it would point in the document where you were. And so I was tasked to we need to improve this, it sucks. So I started looking at the code, and I was like, how do you do one of these trees? So I looked it up, and I'm reading this I think it was one of those Code Academy, no, that's not the right word, but one of those C# programmers things, and I go, these variable names are very familiar. And I go look in the code, and it was the exact same thing that somebody had posted to the site. And it's not like Stack Overflow where they give you license to use that thing, right? So that Stack Overflow has I think it's the Creative Commons license on all the stuff there. This was somebody's proprietary blog where there was no copyright on the code in our product. So as soon as I told my manager that, we had to rip it out and completely re-implement it. So yeah, that's it is literally a liability to your company for you to do that. So yeah, don't, understand things. And if you have any questions, ask. That's the other thing, right? So if you're thinking about using something and saying, ooh, I don't know where this falls, ask. I'll be happy to let everyone know. Questions? Yeah, we can be honest. We're not it's not back in the days where we didn't have internet, where all we had was a book to look at, right? So there's a lot of resources out there. Help yourself, educate yourself, but know what you're doing. Okay, and I could change the syllabus if stuff has to happen. Kind of standard disclaimer. Anybody have any questions on the syllabus? Anything there? Yeah.
Do we bring our book to the class?
Can you?
Should we?
Oh, should you? No. I don't know. I was going to say maybe if you're really short and you can't see over the person in front of you, you could use it. But it's not that big, so I would say no. I wouldn't bring your book to class. Do you have to bring books to a lot of classes? No? Okay, just curious. More questions? All right, so let's look at the first project. All right, so you have a week to do this project. It's 2 parts. First part, sign up for the course mailing list. So do that, put your ASU ID. I don't care what email you use, whatever. Doesn't matter to me. Just sign up before next Monday to get 10 points. Right? Pretty easy. Good. Okay. So the other part is so this is what I say. This is an easy programming assignment. It should be. So write in C or C++ a slightly advanced Hello World application. You're going to write a program that reads from standard in a string, an integer, and then your program is going to output that many times the string hello world with a new line. So example, if your program's given an input of 1 to standard in, you output hello world. And you're outputting hello world with a /n, the new line character, not. So output of just hello world is not correct because it lacks the trailing new line. Hello, this one is not correct because there's multiple spaces here, right? It's kind of hard to see in HTML, but that's also not correct. This hello world is also not correct because there's no space in between hello world, and there's also not a new line. This is also not correct, hello world /r/n, because the new line character is only /n. So you may be thinking to yourself, man, that sounds crazy. Why would we be so strict on this? And the reason is, well, you got to start thinking like the computer, right? So what happens if you forget a semicolon in your program? Huh? Yeah, the line ends, your program crashes, it won't compile, it doesn't do anything, right? You made one mistake, one little error, but the whole thing doesn't work. So that's the same thing here. So you have to get in the habit of implementing exactly the specification that we give you, and that's why we have this very small practice homework. Okay, so yeah, if you're given the input of 5, you will, let's make sure I did this, 1, 2, 3, 4, 5. Yeah, okay, so 5 hello worlds. All right, so hopefully this works. Okay, so that link there will take you to the link to the project submission site. The URL is, I don't know, CSE340.fulton.asu.edu. I don't know why these things are so long, but they are. Let's see, you will click here to register. Mosin will be emailing everyone very shortly your verification code to your ASU account that's affiliated with the school. So you just put in all your information here. You can log in. Oop. I go back. I see the problem here. All right, well, this is when you break your rule about not using your own web browser. All right. Okay, so LastPass knows my password. I don't even know my password. So I type login, and I sign into 340. It tells me these are the list of projects. Then in here, I can look at the makefile. So this will actually help me compile my code. And this is the exact makefile that Mosin's system uses to compile your code. A test script to test your code, a zip file with some test cases, and this awesome programming projects guide, which I think, so Mosin, the lead TA, wrote this awesome guide about how to program projects for 340. So this is 12 pages. So it tells you about all the test cases. It tells you how the test cases are run. It shows you that there is no room for error on the outputs. It talks to you about input-output redirection, so you can develop your own test cases. She's got an example here. The test script that you have for grading. Let's go to, okay, the development tool. So this is really important. So, to make sure that we can compile your code and that you can compile your code, we're standardizing on CentOS 6.7. Yeah, there's a question. It's in the front. Was it you? No. I see a hand out of my eye. Okay. So this is the same, I believe this is the same version that general.asu uses. So if you want to use that for development purposes, you can. It's also the same thing that's on the second floor in the Brickyard, those computers in there. The easiest thing to do is to, where is it? Okay, it talks about make files, installing CentOS on a virtual machine. So there's all the instructions, everything here is free. You can have CentOS running on a machine here, just like I do. Hopefully if I click this, it'll work and everything won't die. So literally I installed this just by following those exact same instructions. So now I have, if this ever boots up, a machine where I can compile on, and that version of GCC that I'm using here is the exact same thing on the submission system. So that when I go to submit my project, I can make sure that it's correct. So yeah, here's all the instructions you need. And so now I can submit, let's see, teaching projects. I can submit my hello example, submit it, and it says, hey, passed 2 tests out of 2. Yay, 100%, awesome. And I can look at all my submissions, and it gives me like some of the output, all that stuff. So the big part about project 1 should not be the programming. So let me go back to the thing here. So the programming on this project is intentionally meant to be very easy. The real goal here is to familiarize yourself with the submission process so that when we start having complex programming projects, you'll know how to submit to the system. Yeah?
What are the instructions for that?
What are what instructions?
For signing up for
Oh, right. So there's a link on, yeah. So on the projects page, there's a link to these guidelines. So you can even get to them without worrying about the course submission thing. And then Mosin will be sending emails with that verification code that you need to create an account on the Turn-In system. Yeah?
Will we be graded on anything besides passing tests?
Maybe. So I would say probably not. So we will go off the test cases. We may, for various projects, have the graders and TAs go through and look at them just so that we can, I don't know, if you somehow hard-coded the test cases or something, we could give you some feedback and reduce your score. But yeah, you know, that would be kind of mean, so I probably wouldn't do that unless it turns out we need to. Any other questions? So, okay, so back to the note. So if this assignment takes you like significantly longer than on the order of an hour, you should seriously consider about not taking this class and taking it some other time. The submission stuff, okay, maybe, but this is a slightly more advanced Hello World, and if you can't do that, you're gonna have serious problems doing the programming assignments. So consider this kind of a self-check before we start. Other questions on the assignment, the submission system? Yeah?
Do you have to set it, or do you use like Visual Studio?
So this is the requirement. Your code has to run on CentOS 6.7 on our submission server. If it doesn't, then you might as well not do anything. So if you're willing to develop it in Visual Studio and then make sure and get that code working on CentOS 6.7 with the exact version of GCC that we're using, that is fine. But know you're taking a risk by doing that. So that's why we have this standardized system so that we can make sure that everybody's using the same thing. That way, because what happens is you submit, it doesn't work, then you say, but it works on my computer, right? That's like the classic, anybody doing an internship as like a tester or something like that? Some people? Yes, that's like the classic dev thing. Like, well, it works on my machine. It's like, yeah, but it doesn't work in production, so your code's crappy and it doesn't work. So like, go fix your code. So we want to avoid those issues and get you in the habit of getting on a standard and doing everything the same. Yeah? So yeah, OS X is a little bit tricky. So, I mean, I developed this little application in OS X with, I think actually the newest versions don't even have actual GCC. I think it's linked to Clang. So you definitely could run into problems there. So that's why I installed CentOS. I mean, it's not very big. It's kind of small, and honestly, you should be getting very familiar with Linux these days. That's also a selling point to employers, is saying like, hey, I have a Linux system on my box. I know how to configure it. I know how to use it. I know how to compile on it. Like, that's good. Yeah. There's other questions. Hands? Yeah.
So VirtualBox is like, it says it has problems with Windows 10, so
Send us a link. I mean, you can use VMware. I think they have a free version on all the platforms except for this one. So yeah, either VirtualBox on the Mac or VMware on Windows. That's what I'd say. Yeah.
Does CentOS compile C++14?
Can CentOS compile C++14? I have no idea. You'd have to look at the version of the compiler for that. So if you want to use anything special like that, then you can change your make file so that you're using whatever compiler flags you need for that. But if it's not on that system, then don't count on it. Also related to that, if it turns out it's somehow technically, physically impossible for you to get a VM running on your system, tell me and we can find a system for you to be on. Because yeah, you should also have general. I think general should work too, or the lab machines. A lot of choices. More questions? Yeah.
Actually, so imagine the code works on my computer and I submit the project, and it turns out that it doesn't work out over there. Do I lose my points, or can I resubmit it?
You can resubmit it. It's got to work on the machine. So the question comes down to is why doesn't it work? So if you have the code on your computer, you say it works, you submit it to the thing, and then you wait till the deadline expires, and then you go, but it worked on my machine, and it turns out there's you made actually a technical error, and I've had this happen where people submit the version on their Windows machine when they've been testing on the Linux VM, and of course that one doesn't work on our Linux servers. So it was a problem on their part. So that's kind of also a good point that's in that essay that I sent out. So assume that the bug is in your code first. Come to us and show us that that it actually is a bug in our code. There's a submission system, and you can send that to us, and we'll try and fix it. More questions? Cool. All right. You didn't think that was all we were going to do today, did you? Yeah.
A problem that I have with going fast is I had like a space that I couldn't visually see what was the difference. What the difference was. Is there a way to, if say for instance I do submit something, I just can't find it. I just can't find this problem, and that problem exists.
Yeah. So that's the big thing, especially with Windows and Linux. That's why I say probably don't develop in Windows, because the default line endings there are, I think, /r/n, and the default line endings in Linux is /n. So oftentimes you can completely mess things up if you submit what looks like identical versions. So you can use a hex editor. There's a tool, hexdump. I think HD is installed by default on Linux things. You can look at the raw bytes and see like, those aren't like an OA like they should be at the end.
So potentially we could miss out on a lot of points just for
Well, that's why you have a lot. I would say you got to start early. So you don't want to wait on these assignments. Submit, and that way you can verify. So the golden standard is, right, you test it on a CentOS 6.7 machine. It compiles there. You submit exactly that version onto the submission site. And then if it doesn't work, then we have problems. But if that should work. More questions? Yeah.
Will these slides be posted to your website?
Yes. So the slides will be posted. The lecture recordings will be posted. Also, some notes that I have from Dr. Bazzi will also be posted. So it should be ample material plus links to book stuff. Any other questions before we get started? Or is this the classic keep asking questions about the syllabus so we don't have to do any lecture stuff? I know these tricks.
If we submit and there is an error, will it show us the compiler errors?
Yes. Yes. And if these things I'm saying are not the case, then let me know, because Mohsin has maintained this system. He's been using it for a long time, so he has a lot more experience with this submission system. So if there are things like that we can improve, I think we're happy to do that. Anything else? All right. Okay. Oh yeah. So comment about the notes. Yeah. So you're all adults here, I have to assume, right? So it's up to you whether you take notes in class or you just listen, or I don't care, whatever. Whatever you want to do is fine. I'm not going to force anything on you. So I wanted to kind of start this class off. Yeah. Yes, the lecture slides will absolutely be online. Yes. And if they're not, let me know. But I'll wait until I'm done with the whole topic before submitting it online, right? I'm not going to do it like piecemeal. So after these slides are done, we'll post those. After the next lexical analysis slides are done, I'll post those. Yeah? Is all the information that you can work like lecture on from the book? It's a good question. I'd say no. Especially, so I'll be using some slightly different terminology. I mean, in general, yes, the ideas and concepts are very similar. I'm not following the book chapter for chapter, though, and there's things we're definitely going to talk about in class that are absolutely not in the book because they're kind of advanced and really cool. So the slides are good for that. There'll also be notes for those. Yeah? No. Good try. Maybe in the future, but we'll see. 'Cause, you like to make improvements and changes and stuff even like right before. So. Okay. So what is a programming language? This is not a rhetorical question. I'm asking what. So I think most people are like a junior-ish area, right? Junior, senior, somewhere in there, right? You've been at this kind of a long time. So you've been doing this, right? What is a programming language? Yeah.
Much more readable interface that allows us to tell the computer what to do without giving it a bunch more.
That's pretty good. A much more readable interface to tell the computer what to do besides giving it ones and zeros. Yeah, that's good. Anything else? Yeah.
It has a well-defined syntax and semantics.
Yeah, so some well-defined syntax and semantics. We're going to get all into that. I kind of like, it's a way to communicate instructions to a machine, right? So that's very similar to that example. So we want to tell the computer what to do, but is that the only definition? And here I think definition may be a little tricky, but what's the other purpose of a program or a programming language? Yeah. Yeah, so other people can interpret and read your work. I'd say that that's almost, honestly, once you leave academia and you go into industry, you're going to spend a lot more time reading other people's code and cursing them that they wrote this code in this way until you finally realize, oh, they did it because they had all these other constraints that I couldn't think about. And then hopefully you'll start writing your code in a way that future you, in a year or 2 years from now, when you have to fix a bug there, you'll be able to actually do it. So yeah, that's definitely one of them, I think. It doesn't have anything to do with the computer at all, right? You're communicating to your teammates, future developers, people that may use your library. You're telling them what this system or process should work. Any other kind of uses? So what about communicating an algorithm, right? So you may not care that, you guys have all taken data structures and algorithms, right? So oftentimes you look at things there that's, pseudocode, right? It's not even to describe instructions to another person, but it's to describe how an algorithm works, operates, all that kind of things. Describing some sort of process. It may not necessarily be an algorithm, but it may be, okay, do this, take this thing, put it over here, wait 30 seconds, call Google, get the response from Google, put that data in here, mix it around, and throw it in here. Right? That could be some kind of process that the programming language describes. We talked about this, communicating a system to another person. I will say this is a very important point that you want to keep in mind as you go, because it comes up a lot. Oftentimes you think you're not actually writing, talking to the computer, you're talking to future people. So kind of already alluded to, how does the computer understand your C or Java or Python code? Is it magic? Yes, it's all magic. You just like throw together random things, and you've learned through trial and error, and probably lots of error, like in my case, what compiles and what doesn't compile, and at some point it like magically executes, right? So the answer to that is no, it's not magic, right? There's nothing magic here, and that's honestly why I love computer science and computer engineering, all that stuff, right? Because you're learning how the whole thing works, and that's part of what this class is designed to do, is we're going to peel back that curtain and realize, oh, it's just programs and algorithms all the way down, right? From that your Python code gets interpreted by a Python interpreter, which was written in C and compiled by a compiler to assembly code, and that's interpreting your Python program and executing it and doing what you want it to do. But you feel like, hey, I'm just programming a Python program. So we talked about this. You kind of gave away my awesome graphic. So the CPU understands assembly instructions, right? So that little hardware chip needs, and I guess this should be like a square or something. That chip understands assembly language like ones and zeros, right? And so, but I don't know about you, but it would be incredibly tedious to program with a keyboard with just like a bunch of 1, 1, 1, 0, 0, 1, 0, 0. You can do it. I've done some stuff where you like patch binaries to try to fix vulnerabilities, and so you have to like look at the assembly code and be like, oh, if I change that 8 to a 9, it'll flip and be, instead of an if greater than, it'll be an if less than, which means that it skips this condition. But you don't want to program in that, right? So we want some abstraction away from the machine, and so then once we start building these abstractions, we build and build and build. So yeah, this is kind of what I talked about earlier. So programs, right? It's all programs. Programs translate your intentions, what you, the programmer, want to have happen, into assembly language that the CPU understands. So there's a couple of these. I'm going to go over, define some terminology. So compilers, maybe we want to take a stab at defining what a compiler is. Everybody looks away from my gaze. Yeah?
It's a program
Yeah.
that takes certain, I guess, instructions or keywords and
Turns it into
stuff.
stuff. That's very general. It's probably so general it's correct. Yeah, I'd probably say it's kind of got a strict definition. Generally, I like the more general definition of a compiler where it just translates from one thing to another, right? So C program to an executable. It's becoming more often now that people have a very narrow definition of what a compiler is. Like a compiler translates a programming language to an executable binary. What about an interpreter?
Translates one language into another.
Translates one language into another? I would say no. Good close. Line by line, what does that mean?
Doesn't take the whole program at once.
I can't see you. Okay, what?
Doesn't take the whole thing at once.
Doesn't take the whole program at once. Maybe. What was that? Wait. Sorry. Yeah? Doesn't convert the program to byte code. Yeah, I'd say that's almost there. It's getting closer. Yeah. Wait, just a second. Now we're getting into crazy semantics. Is the virtual machine for Java an interpreter? Maybe I'll talk about that in a second. Kind of. What? Somebody? Yeah? Right. So yeah, I'd say an interpreter translates and executes. I'm missing some S's, but translates and executes a programming language. So it understands it, right? It does that part of the compiler, but then it actually does the computation itself. So yeah, yes, the JVM is an interpreter. So the Java compiler does what? The Java C? What does it take in? Come on. So the Java compiler, what does it take in? Java. And what does it spit out? bytecode, Java bytecode, right? JVM bytecode. So in the JVM, what does the JVM take in? It takes in bytecode and then it executes. I wouldn't say it outputs, right? Because we don't know if it ever outputs. But yeah, so it does some computation. So yeah, those are where those two lie. What about transpiler? Actually, I'll be honest, I hate this word. But people actually do use it, so that's why I'm making a separate category for it. Anybody want to take a stab at what this means? Yeah. Perfect. Yeah. So this translates one programming language to another programming language. Anybody know of any good examples of transpilers? Wait, just a second. Oh, nice. So a MATLAB to Python compiler. Yeah, that's cool. Yeah. What is it? Oh, Jython. Yeah. Yeah, I'm trying to think about, yeah, you could say, yeah, so it does compile Python. Well, maybe I'd say that's more of a compiler because it's compiling it. Does it compile it to the bytecode? Okay, yeah, we're kind of splitting weird hairs here. That's why I don't like any of these definitions, because to me, those are all compilers, because compilers translate. Yeah? I would absolutely think that counts. Yeah. Exactly. So the Python 2 to 3 compiler, right, is an automatic program that converts from Python 2 to Python 3. Yeah, so a Python 2 program isn't necessarily a Python 3 program, so they are different languages. Yeah. Anything else? Anybody know of any of the crazy JavaScript stuff? Or like what? What was it? I can't. You got to raise your hand. The acoustics here are super weird. You sound like you're coming from everywhere at once. Yeah. What does Babel do? Ah, okay. So so it down converts. So it basically adds in the non-existing language features to support backwards compatibility. That's cool.
SAS to CSS, even though it's not the way programming language.
Absolutely. I think those things, see, that's why I think these are so important. So I consider all those compilers. You can split hairs of compilers, transpilers. But yeah, so those are things that people may not think about. So being able to translate from like SAS, what is that? Is that the one, SAS to CSS? So like the compiler there, right? So that's a better way of doing CSS because you can assign variables, you can have inheritance, all this cool stuff that makes cascading style sheets super difficult to program in. And they said, hey, we can write this awesome, cool language to actually help us do that and make it easier to write CSS. What about, is it ClojureScript, one of the JavaScript ones? That has this like completely different syntax, but it compiles to JavaScript. Rhino for Java? What is that? Java to JavaScript? Yeah, and Google has something similar, right? With GWT, the Google Web Toolkit, that takes a Java program that describes a web page and compiles it to JavaScript. Yeah, so this is part of what I want to get across is that like the stuff that we're learning is how to do all these, build all these tools, because oftentimes it is the best tool for the job, is to say, hey, you know what? Man, CSS is terrible. I wish there was something better. Hey, I can create something better using the things I learned in 340 to take in a new awesome language and spit out CSS. So cool stuff. So yeah, that's what, so it leads me in right here. So we're going to study how these programs, the compilers, transpilers, interpreters, are able to translate a high-level programming language into something that a computer can understand. And so to do this, you got to know we're going to be talking about two different things here. And so this is also why I really, really like this class, because we talk about some of the theory stuff, right? So why do we care about theory? I know this is kind of a leading question. So I'll take it. It's like, we don't care, said someone. Yeah, well, we do kind of care. But why? Why do we care? So assuming we care, why? You answer a lot. I'm going to go with somebody else. No offense. Yeah?
It makes us better.
It makes you better. In what way? Better humans?
Programmers.
Better programmers? I'd say that's definitely true, yeah. Let's go here. Yeah, so it gives you the framework. So yeah, that's really good. So yes, it'll make you a better, well, I don't know if directly it'll make you a better programmer. I don't know that you go, man, I know the formalism behind regular expressions. I'm amazing. But I think it helps you think about those things. And specifically, I think in this context, it helps us to define what we can and can't do when defining or creating a programming language or something we want to interpret or compile, right? So without the theory, we just say, you'd say, well, before you took this class, you'd probably maybe never think of ever creating a compiler or translator or programming language. But after this class, you're like, hey, that's not magic. I know how those things work. I can do my own thing. But man, this theory helps me know what I can actually do and what I can't do, and how I should actually design my language. So I kind of talked about this. So yeah, there's all kinds of things. So anybody hear of the company called Fog Creek Software? Yeah, some people. Can you raise your hand so people don't think that I'm just crazy? Okay, good. So their company, anybody actually work for them? That'd be a long shot, but okay. So their company in New York, they make, I think their big thing now is bug tracking software, I want to say. And so they, for a long time, had this big application written in, I think, like Visual Basic, which, who's programmed in Visual Basic? Yeah, like one of the worst languages known to man. Or maybe you like it, I don't know. But my opinion is I do not like Visual Basic, but they wrote this huge application, but their clients kept demanding, like, we want a PHP, we want to host it ourselves, and we want to run it on PHP. So they have a lot of smart people there. They said, wow, it would be really terrible for us to maintain two versions of this application, right? The PHP version and the Visual Basic version. Then when we have bugs in one, we have to make sure we fix it in the other, and we have to duplicate our test cases. It's going to be a nightmare. So they actually wrote a language to compile from, I think, Visual Basic to PHP. And then they started like improving it and ended up creating their own language to write the web application in. And that allowed them actually to then go from their crazy language to now I think they've completely moved to C#. So all of that was like compilers at each stage, translating and improving for business purposes because it made sense. And so yeah, so these are the skills that are very important and they are powerful. And I think they do make you a better programmer, maybe not in your day-to-day, but that time that you're like, wow, I can create a compiler here. This is going to be awesome, and it's going to save me and this company so much time. Then you go to your boss and say, hey, I just saved the company millions of dollars a week. How about a raise? And then it'll be good for everyone. OK, so now I want to talk about some programming languages. So what is this? We can use abbreviations or acronyms for this specific language. So for those that haven't seen it before, I mean, does this look like any programming language that you've ever used or programmed in? Yes, you've used this? What's the biggest BF program you've written? OK, so about this size then. OK. So I didn't even write this. I stole it offline. So yeah, so this is a programming language called, I'll shorten it to BF. You can look it up afterwards. Running this program in a BF interpreter outputs hello world. And because you guys have taken computing theory, right? So you know about Turing completeness? Yes. More or less? OK, so if you haven't, this means that anything you can do in one programming language that's, I'm trying to remember the words, that is Turing complete, you can write that program in another language that is also Turing complete. So BF is Turing complete. You could write Microsoft Windows in BF. You could write Firefox or Chrome. It would be crazy. I would not, suggest you do that, but you can. And so if you want to go, there'll be a link here where you can actually run this online with a JavaScript BF interpreter. And kind of what this whole class is about is the mystery behind, like, how does it go from those symbols to actual computation? Yeah, there's a question in the back?
Oh, never mind.
OK, forgot it. OK, what's this? Nothing.
It's your name.
It's my name. Part of it's my name. ASU is my name. No. The class name. This is actually a program. Yeah, so there's actually a programming language that somebody developed that is Turing complete. And this I changed all the spaces to underscores, the tabs to /t, and the new lines to /n. And using these 3 characters, they created an entire programming language called whitespace. And this program outputs hello world of spaces. That's it. So the other really cool thing is it ignores everything that's not whitespace. So you can actually embed a white space program inside of another programming language or like inside of an image. So yeah, you can do like double computation. It's kind of cool. And yeah, here's a link you can go to check out all the white space interpreter written in a bunch of different languages. What about this? This language? Everybody familiar? Python. Python 2, right? Because you got to be, doesn't have the parentheses. Yeah, so Python, right? So Python takes in some input like this, prints out hello world. What about this? Haskell, yeah, good. Somebody got it. Yeah, so this is Haskell code. This is a crazy programming language that I really like that we're going to actually talk about some of its features in the context of this class. And what about this? Oh, shoot. This is the problem. This is x86 assembly specific for a specific assembler that outputs hello world. And so the point of all this is to show you that in some ways, what you think of as a programming language is kind of arbitrary, right? I mean, you could code anything in any language. So yeah, I guess so. Are all of these programming languages? Yeah? Would you actually want to code in all of them? No? Are none of them programming languages? Maybe I just made one of those up. Some people have heard of them, so I need to make up my own specific language and then do that. Some of them, maybe some you'd use, they have different purposes. But the point of this class and the whole point is what we're going to study is how does a program, either a compiler or an interpreter or something, how does it take in essentially bytes on one side, right? Raw bytes, and perform some output or do some kind of computation in a way that's useful. So I like to think of this as kind of a pipeline. And so we have source code coming in on one, right? And that's just made up of bytes. And then we have some lexer that's going to interpret those bytes and generate something useful or something that our computer can understand. Because we really don't want to be worried about individual bytes, right, the whole time. So then those tokens are going to get passed to a parser. And that job is to create a parse tree. So it's going to understand what the program looks like. And then we're going to actually analyze this tree to say, does it make sense, right? Have you ever compiled a program that compiled and then you ran it and it crashed? I think everybody should be nodding their head. If you haven't done that, I don't know. You're like the perfect programmer and you should have no problems with this class. Right? And why is that? Well, because maybe the program wasn't valid or maybe you did something wrong. A lot of these errors, we can check for it early. So we can say, do the types in this system match? Does it make sense to add, to multiply I'm trying to find an example that doesn't work. Does it make sense to multiply like a string by a fraction or something? Like, I think that doesn't work in Python. Python messes up that example, but a string multiplied by a decimal number, right, doesn't really mean anything. So we should reject that program. And then hopefully that outputs some valid parse tree where then some other component can say, okay, now let's compile that, let's interpret that, or output something else. Okay, so we touched on this a little bit. So these are going to kind of be two of the three main things we're going to talk about. So syntax. So what is syntax? Somebody want to raise their hand? There's too many of you to talk at once. I just got yeah. So syntax is how you write the program? Rules for, yeah. So I like to think of it like, what does it mean to look like what does a valid program look like, right? So we just don't want any arbitrary pounding on the keyboard. We want to have some well-defined way of what it looks like. And who's that for? Us? Yeah, exactly. So us as programmers, so we know how to write a program that at least looks like a valid program. What about semantics? Raise. Okay, yeah. What is it actually what? What was that?
What is the program trying to do? Does it make sense?
Right, so what does the program actually do? Yeah, so this is that kind of thing. What does it mean for a program to be valid? So one is talking about what does a valid program look like? right? And the other one is, what does it mean for a program to be valid? So this is where things like type system or defining a variable before you use it in C, right? Those are all under semantics. And before anybody asks the question, these kind of do bleed together because you can enforce some semantic things in the syntax, but we don't have to get into that too much, especially at this stage of the game. What about correctness? Doesn't that make a program valid? Does it? I don't know. I mean, so I like to think of it, is the program the correct one for the job? Is this program right for the task? And that's kind of a high-level thing. I like to think of it from a security perspective, so I always think, like, does this program have any security vulnerabilities, right? Because a program with security vulnerabilities is obviously not correct. So what I try and like to do is, can we write a static analysis or some kind of tool that analyzes the program and can try to analyze this aspect of correctness? But doing complete correctness, your code is 100% correct, it's very, very difficult. Questions? Yeah?
So it depends on the job, right? Maybe like security-wise it's not correct, but logic-wise it's correct. So it depends on the different perspective how we are looking for that.
Yeah, so the question is, does it depend on the job, in essence? Yeah, and so it depends. I mean, correctness is very vague because you as the programmer, you may get a beautifully detailed, amazing spec that tells you exactly what you should do. You go do that, you write bug-free code, it's amazing, and then 3-4 months later, you take it to the user, and you're like, look at this, I implemented this program exactly to your spec, it's amazing. And they go, you know what? That was like 3 months ago. I don't really need that one feature anymore. Can we like change that and make that font bigger and like put that box over here? And so you have like shifting requirements of what even is correct. So yeah, it's a very, very nebulous topic. And I always get to the point where it's like, okay, if you have a spec that's good enough that you can mathematically verify that the code matches the spec, well, then you're just going to verify if your code has any of the bugs in that spec. So now you have to write things exactly right twice. You have to have a spec that doesn't have any bugs and an implementation that doesn't have any bugs. And I guess a checker that doesn't have any bugs. Unless you use it to check itself and then you get into a hole. Your head explodes. And any other questions? We'll rant. All right. Well, even though I guess it is the first day. All right. I guess we'll stop here, and we'll see each other on Wednesday.